Dear students, in this class we will solve problems on limits. Let's have a look at the first question. Limit extends to a x power p minus a power p divided by x power q minus a power q. There is a direct formula, so the answer is p by q into a power p minus q. If you know that formula, directly you can write the answer. Okay. But if your question is, sir, if you don't know the formula, then what we should? Then also you can solve this problem. Let me tell you how. Limit extends to a x power p minus a power p divided by x power q minus a power q. If I directly apply the limit, I am going to get a power p minus a power p, that is 0. Denominator a power q minus a power q, that is also 0. 0 by 0 is an indeterminate form. When it is of the form 0 by 0, we can use L-Hospital's rule. Okay, that is, what does L-Hospital's rule say? Differentiate when it is 0 by 0 or infinity by infinity form, then differentiate both the numerator and denominator separately, not by using quotient rule. Separately you differentiate. Okay, so let me differentiate this numerator. We get p into x to the power p minus 1 divided by derivative of the denominator is q into x to the power q minus 1. Okay. So here, now if I apply the limit, we are going to get p by q into a power p minus 1 divided by a to the power q minus 1. That's equal to, if I take it numerator, a power p minus 1 into a power minus q plus 1. So put together, it will become a to the power p minus q. Okay, which means first option is the correct answer. Okay, let's have a look at question number 2. Limit extends to 7x square minus 11x minus 6 divided by 3x square minus x minus 10 is equal. If I directly apply the limit, let us see what happens. 7 into x square is there, so 7 into 2 square, which is 4, minus 11 into 2, 20, minus 6 divided by 3 into 2 square is 4, minus 2, minus 10. Let's have a look at the numerator. 7 into 4 is 28, 28 minus 22 minus 6, that is equal to 0, divided by, in the denominator, 12 minus 2 minus 10, which is also equal to 0. So this is of the form 0 by 0, an indeterminate form. Then what we can do? We can go for L-Hospital's rule. So differentiate the numerator. What do we get? 7 into x square is there, derivative of x square is 2x, so we get 14x. Minus 11 into derivative of x is 1, so 14x minus 11 we get. In the denominator, we get 6x minus 1. After differentiating, this is what we get. Now you apply the limit. 14 into 2 is 28. 28 minus 11 will give you 17. Divided by 6 into 2, 12 minus 1 is 11. So the answer is 17 by 11. First option. Okay. Let's have a look at question number 4. Limit extends to 1, x square minus root x divided by root x minus 1 is equal. Here if I directly apply the limit, first term is x square, so that will give you 1 square, which is 1, minus root of 1. Root of 1 is also equal to 1. 1 minus 1, 0. Numerator is 0. Look at the denominator. Denominator is root x minus 1. Root x, when I put x as 1, root 1 we get, which is 1. 1 minus 1, that is also 0. 0 by 0, an indeterminate form. Okay. So, now I will use L-Hospital's rule. Derivative of x square is 2x minus derivative of root x. Derivative of root x is 1 by 2 root x divided by derivative of root x, which is 1 by 2 root x. Apply the limit as x tends to 1. Put x equal to 1. 2 into 1, that is 2, minus 1 by 2 into root 1. Root 1 is 1, so we get 1 by 2 there, divided by 1 by 2. That's equal to 4 minus 1. 3 by 2 divided by 1 by 2. That's equal to 3. So the answer is 3, third option. Let's go to the next question. Question number 6. Limit extends to 0. Fifth root of 2 plus x minus fifth root of 2 minus x divided by sin x. Okay, I'll rewrite the given problem in this way. Fifth root of 2 plus x can be written as 2 plus x to the power 1 by 5 minus 2 minus x to the power 1 by 5 divided by sin x. Okay. Now if I apply the limit as extends to 0, I mean put x equal to 0, you will get a 2 to the power 1 by 5 here, minus 2 minus 0 is 2, 2 to the power 1 by 5. 2 to the power 1 by 5 minus 2 to the power 1 by 5, that will be equal to 0. So numerator is 0. Denominator is sin 0, that is also 0. So 0 by 0, an indeterminate form. Therefore, we can go for L-Hospital's rule. Derivative of 2 plus x whole power 1 by 5, that will be 1 by 5 into 2 plus x to the power 1 by 5 minus 1. 1 by 5 minus 1 is minus 4 by 5 into the derivative of 2 plus x. Derivative of 2 plus x is 1. 0 plus 1 is 1 minus derivative of the second term there, that will be 1 by 5 into 2 minus x to the power 1 by 5 minus 1. 1 by 5 minus 1 is minus 4 by 5 into the derivative of 2 minus x. Derivative of 2 minus x is minus 1. Okay, let's have a look at the denominator. In the denominator we have sin x and its derivative is cos x. Okay, apply the limit as extends to 0 now. So what do you get? 2 plus 0, that is 2. So 1 by 5 into 2 to the power minus 4 by 5. Here minus into minus it will come plus 1 by 5 into 2 to the power minus 4 by 5 divided by cos 0. When I apply the limit, cos 0 we get, which is equal to 1. So 1 by 5 into 2 power minus 4 by 5 plus 1 by 5 into 2 power minus 4 by 5. Together it will become 2 by 5 into 2 to the power minus 4 by 5. Okay, that option is not there. Then what do? I'll write this 2 as 2 to the power 1. 2 to the power 1 into 2 to the power minus 4 by 5 can be written as 2 power 1 minus 4 by 5, which is 2 power 1 by 5. So 2 power 1 by 5 whole divided by 5. 2 power 1 by 5, which is the fourth option. Okay, let's have a look at the next question. Question 7. Limit extends to 0. Root of 1 plus sin x plus sin square x minus 1 divided by x is equal. In this question, if we directly apply the limit, we are getting sin 0 here. 1 plus root of 1 plus sin 0 plus sin 0. Sin 0 is 0. So you will get root 1 as the first term. Root 1 is nothing but 1. Minus the second term is 1. 1 minus 1. 0. Numerator is 0. Denominator also, when I apply the limit as extends to 0, denominator also will become 0. So 0 by 0, which is an indeterminate form, so I will go for L-Hospital's rule. So that numerator looks like root x. What is the derivative of root x? Derivative of root x is 1 by 2 root x. So the derivative of that expression is 1 by 2 root of 1 plus sin x plus sin square x into, now the derivative of 1 plus sin x plus sin square x, derivative of 1 is 0, derivative of sin x is cos x, plus now the derivative of sin square x, derivative of sin square x is 2 sin x into cos x. Okay, minus 1 is the derivative of 1 is 0, divided by, in the denominator, derivative of x, which is equal to 1. Now put x as 0. When I put x as 0, here cos 0 is 1 plus 2 into sin 0 into cos 0, that will be 0 anyway. So numerator is 1. Denominator 2 into root of 1 plus 0 plus 0, which is equal to root 1, which is 1. So answer is 1 by 2. 1 by 2, fourth option is the correct answer. Let's move to the next question. Question number 8. Limit extends to 0. 1 plus x to the power 1 by m minus 1 minus x to the power 1 by m divided by 1 plus x to the power 1 by n minus 1 minus x to the power 1 by n is equal. So if we directly apply the limit as x tends to 0, this numerator will be 1 power 1 by m. 1 power 1 by m is 1 minus second term is also 1 power 1 by m. 1 power 1 by m minus 1 power 1 by m, that will become 0. In the denominator we will get 1 by 1 power 1 by n minus 1 power 1 by n, that is also 0. So 0 by 0. For this problem also we can go for L-Hospital's rule. Okay. So what do you get when you differentiate 1 by m into 1 plus x to the power 1 by m minus 1 into the derivative of 1 plus x, which is 1, minus second term, its derivative is 1 by m into 1 minus x to the power 1 by m minus 1 into the derivative of 1 minus x, which is minus 1. So this will become plus, divided by, now if I differentiate the denominator, then we get 1 by n into 1 plus x to the power 1 by n minus 1 minus 1 by n into 1 minus x to the power 1 by n minus 1 into the derivative of 1 minus x, which is minus 1. So this will become plus 1. Now if I apply the limit as x tends to 0, here 1 plus n is 1. 1 power 1 by m minus 1, that will be 1 only. This will be 1 by m, that will be 1 by m. Together it will become 2 by m. Similarly in the denominator, 1 by n, because this expression will become 1, this expression will also be 1. So 1 by n plus 1 by n is 2 by n. 2 gets cancelled, this n will go up. So the answer is n by m. N by m, which is the third option. Okay. Question number 10. The value of limit x tends to b root of x minus a minus root of b minus a divided by x square minus b square for b greater than a is. B must be greater than a because otherwise root of b minus a does not exist at all. Root of b minus a, or in general root x is defined only when x is greater than or equal to 0. So if b is less than a, then square root of b minus a, that root of a negative quantity, that does not exist. Okay. Anyway, now coming back to this problem, if we directly apply the limit here, what happens? We are applying the limit as x tends to b, which means wherever there is x, we are replacing that x with b. Then the numerator becomes root of b minus a minus root of b minus a. Root of b minus a minus root of b minus a. Numerator is 0. Look at the denominator. B square, I am putting x as b because we are taking the limit as x tends to b. So denominator will become b square minus b square. That's also 0. So 0 by 0, an indeterminate form. So we can use L-Hospital's rule. Okay. So if I use L-Hospital's rule, then we will get limit x tends to b. Derivative of root x minus a. Derivative of root x minus a is 1 by 2 root of x minus a into the derivative of x minus a, which is 1. Minus, there is a root of b minus a. Root of b minus a, it is a constant, so its derivative is 0. Divided by, in the denominator, derivative of x square is 2x, derivative of b square is 0. Okay. So, now you apply the limit as x tends to b, we get 1 by, this will become 2 into 2, 4b into root of b minus a. 1 by 2 root b minus a divided by 2b. Together, I can write this as 1 by 4b into root b minus a, which is the second option. Okay. Next, 13th question. Limit x tends to 0, root of 4 plus x minus cube root of 8 plus 3x divided by x. Okay, I'll write it in this way. Limit x tends to 0, root of 4 plus x minus, I'll write as 8 plus 3x to the power 1 by divided by x. If I directly apply the limit as x tends to 0, here this will be 4 plus 0, which is 4. Root 4 is equal to 2. And then here 8 plus 0 is 8. 8 to the power 1 by 3. 8 can be written as 2 cube. 2 cube whole power 1 by 3. 2 cube whole power 1 by 3 is equal to 2. So 2 minus 2, numerator is 0. Denominator is also 0. 0 by 0 is an indeterminate form. Okay. So if it's an indeterminate form of the type 0 by 0 or infinity by infinity, we can use L-Hospital's rule. L-Hospital's rule is the easiest way to solve problems of the type 0 by 0 or infinity by infinity. It's a very useful result. Okay. Root 4 plus x, its derivative is 1 by 2 root of 4 plus x into the derivative of 4 plus x, which is 1 minus derivative of this is 1 by 3 into 8 plus 3x to the power 1 by 3 minus 1. 1 by 3 minus 1 is minus 2 by 3 into the derivative of 8 plus 3x. Derivative of 8 plus 3x is 3 divided by derivative of x, which is 1. That's equal to. Apply the limit as x tends to 0. So when x tends to 0, root 4 plus 0, that is 4. Root 4 is 2. 2 into 2 is 4. 1 by 4 minus. Here what happens? Here 3 gets cancelled. And then when I apply the limit as x tends to 0, it will become 8 to the power, 8 plus 0, that is 8 to the power minus 2 by 3. 8 to the power minus 2 by 3. That's equal to 1 by 4 minus. This 8 can be imagined as 2 cube. This can be written as 2 cube. 2 cube whole power minus 2 by 3. 2 cube whole power minus 2 by 3. That will give you 2 to the power minus 2. 2 to the power minus 2 is nothing but 1 by 4. So 1 by 4 minus 1 by 4, we end up getting 0 as the answer, which is the fourth option. Okay. Then let's have a look at 14th question. Limit x tends to 2, x power 5 into root x minus 32 into root 2 divided by x cube root x minus 8 into root 2. Okay. So then limit x tends to 2, x power 5 into root x, that root x I will write as x to the power 1 by 2. And 32 is there now. 32 we can write that as 2 power 5 into root 2 is there. I will write that as 2 power 1 by 2. Okay, divided by x cube into root x is there. Root x I will write as x power 1 by 2 minus 8 root 2 is there. 8 can be written as 2 cube into 2 to the power 1 by 2. Okay, that's equal to limit x tends to 2. X to the power 5 into x to the power 1 by 2. That can be written as x to the power 5 plus 1 by 2. 5 plus 1 by 2 is 11 by 2. Right? 2 to 5, 10 plus 1 by 2. 11, x power 11 by 2 minus. So similarly, this will also become 2 power 11 by 2. Divided by x to the power 3 plus 1 by 2. That will be 7 by 2. X power 7 by 2 minus 2 to the power 7 by 2. Okay. So you just observe, this looks like limit x tends to a, x power p minus a power p divided by x power q minus a power q. It's in this form. And we know that the answer to this is p by q into a to the power p minus q. Okay, if you know this formula, you can directly write. In fact, first problem of today was this problem only. So p by q into a power p minus q. Now what is p? Just compare. P is 11 by 2 and q is 7 by 2. A is 2. Okay. So p by q means 11 by 2 divided by 7 by 2 into a to the power p minus q. What is a? 2. To the power p minus q. 11 by 2 minus 7 by 2. Okay. 2 gets cancelled. 11 by 7. 2 to the power 11 by 2 minus 7 by 2. That will give you 4 by 2. 4 by 2 is 2. 2 square 4. 4 into 11. 44 by 7. 44 by 7. Third option is the right answer. Okay, next. 15th question. If limit x tends to 5, x power k minus 5 power k divided by x minus 5 is equal to 500, then the positive integral value of k is. Okay. See, they have given that limit x tends to 5, x power k minus 5 power k divided by x minus 5 is equal to 500. Okay. Look at this LHS. Limit x tends to 5, x power k minus 5 power k divided by x minus 5. This looks like limit extends to a x power n minus a power n divided by x minus a. You know this formula, right? Limit extends to a x power n minus a power n divided by x minus a is equal to n into a power n minus 1. That is a very well known formula. So that formula I am using here. Limit extends to a x power n minus a power n by x minus a is equal to n into a power n minus 1. So if I use that formula, instead of n we have k here, k into a power, what is a? 5, power n minus 1, n minus 1 means k minus 1 is equal to 500. Okay. So we have this equation now, k into 5 power k minus 1 equal to 500. Now let us put some value for k from the given options. Okay. So from the given options, I will substitute values for k and check which option will satisfy. Okay, let's start with the first option. Put k is equal to 3. If I put k as 3, then 3 into 5 power 3 minus 1. So 5 square you get. 5 square is 25. 25 into 3, 75 we get. But on RHS we have 500. Okay, so 3 is not the answer. Then put k equal to 4. If I put k as 4, 4 into 5 power 4 minus 1, which means 4 into 5 cube we get. What is the value of 5 cube? 5 cube is nothing but 5 into 5 into 5. 5 into 5 is 25, 25 into 5 is 125. And what about 4 into 125? 4 into 125 is equal to 500. Therefore, k value must be equal to 4, which is the second option. Then, 17th question. Limit extends to 0, x square by 1 minus cube root of 1 plus x square. Limit extends to 0, x square by 1 minus 1 plus x square to the power 1 by cube root of 1 plus x square. I am writing that as 1 plus x square to the power 1 by 3. Okay. If I directly apply the limit, numerator is 0, denominator 1 plus 0, there is 1 here, 1 minus 1, 0 by 0. So, we will use L-03. Okay. Derivative of x square is 2x divided by derivative of 1 is 0 minus derivative of 1 plus x square to the power 1 by 3. That will give you 1 by 3 into 1 plus x square to the power 1 by 3 minus 1. That is minus 2. I am just using exponent formula. Derivative of exponent is n into exponent minus 1. So 1 by 3 into 1 plus x square to the power minus 2 by 3 into, now I want the derivative of 1 plus x square. What is the derivative of 1 plus x square? Derivative of 1 is 0, derivative of x square is 2x. So this into 2x. Okay. Now before I apply the limit, I will cancel that 2x. 2x gets cancelled. This 3 will come up. So I will write minus 3 by 1 plus x square to the power minus 2 by 3. Okay? I have cancelled this 2x. So this 3 has come up to the numerator. So minus 3 divided by 1 plus x square to the power minus 2 by 3. This is what we have. Now apply the limit as x tends to 0. Put x as 0 here. When I put x as 0, this will be 1 to the power minus 2 by 3, which is 1. So minus 3 in the numerator and 1 in the denominator. Therefore, answer is minus 3. Minus 3, which is the third option. Okay? Next. 18th question. Limit extends to 0, square root of 1 plus tan x minus square root of 1 minus tan x divided by sin x is up. So if I directly apply limit as x tends to 0, we get tan 0. Tan 0 is 0. Root of 1 plus 0, that is 1. Root 1 is 1. Minus second term also root 1, which is 1. 1 minus 1. Numerator is 0. Denominator is also 0. 0 by 0 is an indeterminate form. So I use L-Hospital's rule. Derivative of root 1 plus tan x is 1 by 2 root 1 plus tan x into the derivative of tan x, which is secant square. So derivative of 1 plus tan x, that is secant square. Minus 1 by 2 root 1 minus tan x into the derivative of 1 minus tan x into derivative of 1 minus tan x is minus secant square x divided by, in the denominator, derivative sin x, which is cos x. That's it. Now I apply the limit as x tends to 0. Secant square 0 is 1, tan 0 is 0, 1 plus 0 is 1, 2 into root 1, root 1 is 1. So 1 by 2 minus. Minus into there is another minus, so it will become plus. Secant square 0 is 1, tan 0 is 0, so we get 1 by 2 there, cos 0 is 1, answer is 1. 1 is the answer. 1 by 2 plus 1 by 2, 1 by 1 is 1, which is the second option. Okay. Look at question number 20. Limit x tends to 0, x minus sin x divided by x plus cos square x. Okay. Now, if I directly apply the limit, numerator is 0 minus 0, denominator is 0 plus 1. That's equal to 0 by 1. This is not an indeterminate form. You can directly write this answer as 0. Okay, when we directly apply the limit, we will get the answer. See, we are so fond of using L-Hospital's rule. Some students use L-Hospital's rule for this also. It's not necessary. You should not use L-Hospital's rule because L-Hospital's rule can be used only when you have 0 by 0 or infinity by infinity. Here you have 0 by 1. This is well defined. 1 by 0 is not defined, but 0 by 1 is well defined, which is equal to 0. First option, that's the answer. Then, 21st question. Limit x tends to 0, sin x divided by root of x square. Sin x by root of x square. Okay. So now, sin x by root x square. What is root x square? Root of x square is nothing but modulus of x. Don't directly write that as x. Root of x square is equal to mod x. Okay. So if I directly apply the limit, I am going to get sin 0, 0 divided by 0, 0 by 0 and indeterminate form. But to differentiate this mod x, at a 0, we know mod x is a very well known fact that mod x is not differentiable at x equal to 0. So we cannot go for L-Hospital's rule. Instead, we will go for left hand limit and right hand limit. Okay? So first I will find out left hand. That's equal. Limit x tends to 0 minus f of x. 0 minus sin x by mod x. That's it. Now x is approaching 0 from left side. When x approaches 0 from left side, it means x is less than 0. That means x is negative. Whenever x is negative, how do we define mod x? Whenever x is negative, mod x is defined as minus x. Okay? Limit x tends to 0, sin x by minus x. As x approaches 0, sin x by x becomes 1. So 0 by minus 1, sin x by x becomes 1. So this will be minus, right? Then I will find right hand limit. Right hand limit means limit x tends to 0 plus sin x by mod x. Okay. Now limit x tends to 0 plus. 0 plus means x is approaching 0 from right side. When x approaches 0 from right side, mod x is equal to plus x because x approaching 0 from right side indicates that x is positive. When x is positive, mod x is defined as x. So we get sin x by x, which is equal to 1. Left hand limit is minus 1 and right hand limit is plus 1. Therefore, the limit does not exist. Okay. So in limits, whenever you see one option as does not exist, then don't think that it always does not exist. Then you should be very careful. You should be cautious. You have to cross check your answer again, just whether the limit exists or not, that you need to cross check. Okay. Now we have seen that limit does not exist because left hand limit is different from right hand limit. Then 22nd question, limit x tends to a, x minus a divided by modulus of x minus a. Again this limit also does not exist. Why it does not exist? Because mod x minus a, as we know, mod x is defined as x if x is greater than or equal to 0 and minus x if x is less than 0. On the same lines, modulus of x minus a is defined as x minus a if x minus a is greater than or equal to 0. X minus a is greater than or equal to 0 means x is greater than or equal to a. And minus of x minus a, that is a minus x if x is less than a. You know the graph also. I will give you one idea how to remember that graph. See, this graph is well known to you. Okay, this is the graph of mod x. Okay, then if this is 1, then this is the graph of mod of x minus 1. This distance is 2, that is the graph of mod x minus 2. Then let's have a look at this. This is minus 1. So graph of that is a graph of mod of x plus 1. Okay? You remember that mod x minus a touches x axis at a. So mod x touches x axis at 0 because there mod x calculated as mod of x minus 0. Then mod x minus 1 touches x axis at 1. Mod x minus 2 touches x axis at 2. So if you look at the graph of mod x minus 1, to the right side of 1, that is whenever x is greater than 1, mod x minus 1 is defined as x minus 1. And to the left side of 1, that is whenever x is less than 1, mod x minus 1 is defined as 1 minus x. Remember this graph. This function mod x minus a is continuous everywhere and not differentiable at a. Not differentiable at a point where it touches x axis. Okay? Because at x axis there is a sharp edge. See, by looking at the graph, we can identify whether a function is continuous or not, and we can also identify whether a function is differentiable or not. To check continuity of a function at a particular point, we should see whether there is any break at that point. If there is no break, then the function is continuous. And to check whether it is differentiable or not, we must see whether there is any sharp edge. If wherever there is a sharp edge, at that point, the function is not differentiable. As you can observe, this mod x has a sharp edge at 0. So this is not a theory, that is how you understand. Okay? So if somebody asks you tomorrow, when do you say that a function is not differentiable, at which point it is not differentiable, don't say if there is a sharp edge, then that sharp edge is not differentiable. Okay? That's not the definition. Definition you know. So that's how you can easily understand that. So whenever there is a sharp edge at a particular point, at that point the function is not differentiable. So mod x is not differentiable at 0, mod x minus 1 is not differentiable at 1, and mod x plus 1 is not differentiable at minus 1. In general, modulus of x minus a is not differentiable at x equal to a. Okay. So this is a brief explanation about mod x minus a. Now coming back to this problem. So by now you must have understood that answer does not exist. Anyway, left hand limit I will find out. Left hand limit means limit x tends to a minus f of x. F of x is x minus a divided by modulus of x minus a. X is approaching a from left side. When x approaches a from left side, x is less than a. Whenever x is less than a, mod x minus a is defined as a minus x. This is equal to limit x tends to a, x minus a divided by a minus x. These two gets cancelled. So you have limit x tends to a minus 1, that's equal to minus 1. Left hand limit is minus 1. Now let me find out right hand limit. That's equal to limit x tends to a plus f of x. F of x is x minus a divided by modulus of x minus a. That's equal to limit x tends to a, x minus a, mod of x minus a. X is approaching a from right side. X is approaching a from right side means x is greater than a. Whenever x is greater than a, mod x minus a is defined as x minus a. These two gets cancelled. So we have limit x tends to a 1 is equal to 1. Left hand limit is minus 1, right hand limit is plus 1. Therefore, the limit does not exist. 4th option is the correct answer. Okay, students, with this problem I will stop today's class. We'll continue tomorrow. Thank you.